Hello dear students, welcome to Tejama YouTube channel. So in this session I'm going to discuss about the synopsis part of the chapter scalars and vectors. Okay, so in this session I will be giving you the detailed explanation for the different concepts which are there in this chapter and important formulae also. Direct formula I will be giving. I will not be doing any derivation like we have the derivation for resulted vector of two vectors by using parallelogram law of vector addition. Derivation, if you want, I will make a separate video and give the link in the description. You can just watch it. As of now, the synopsis for part for the KCET, NEET and JEE level. Okay, so and then I will make one more video to the next level, complicated level, where I will be solving some questions based on your NEET and JEE also. Okay, so if you feel this content is useful, please share it to your friends and make them to subscribe and follow my channel. Thank you so much. Let us start the video without any delay. First of all, what is a scalar? See, scalar is a physical quantity which has only magnitude, right? But no direction. Vectors are having the direction. Scalars doesn't have any direction. For example, we have time, temperature, speed, distance, density, pressure, electric current, potential, resistance, capacity, charge, work, energy, dipole strength. So all these things are the scalar quantities, right? So they have the magnitude, but there is no particular direction for them. But what is a vector quantity? A physical quantity having both magnitude and direction is called a vector, right? Then for example, here we have displacement, angular velocity, acceleration, linear momentum, force, impulse, angular displacement, and we have what is this? Torque. These are all the examples for vectors. Clear? Yes. How do we represent a vector? A vector is represented by taking, let's consider there is a vector like force. Okay, how do you represent? We take the symbol and just draw an arrow on it. That gives you the vector. But in NCERT, some textbooks and the version also, in some text only F will be given, but bold F letter will be given. So bold F letter also will represent a vector. Okay, yes, as of now, while writing in your note, what is that, a board examination answers, you may have to write this symbol, that is arrow mark, where if you consider this arrow mark separately, this end represents the tail and this end represents the head in the direction, that is tail to head gives the direction of the vector, and the length of that what is this arrow will give you the magnitude, and the direction of arrow gives the direction in which the vector is acting. So we can resolve or split this vector into two parts. One is its magnitude. So this is a vector, and this gives the magnitude of vector, nothing but the value, and this is the unit vector, gives the direction. Okay, that gives you the direction. Okay, next we have types of vectors. In that, first one is unit vector, very important one. What is a unit vector? A vector whose magnitude is 1, okay, is called unit vector, that is represented by cap. For example, here we have unit vector along x-axis is I cap, unit vector along y-axis is j cap, and unit vector along z-axis is k cap. Okay, the angle between I cap and j cap is 90 degree, j cap and k cap is 90 degree, k cap and I cap is also 90 degree. Clear? Yes. Now for example, a vector A is given. How to find out the magnitude of vector A? Let's consider vector A here is ax I cap, ay j cap plus az k cap, right? So how to find out the magnitude? We have this vector A, that is ax I cap plus ay j cap plus az k cap, the given vector, divided by magnitude of vector A is given by taking the square root of ax square, that is coefficient of I, and then ay square, okay, and this is square plus az square. So square root of ax square plus ay square plus az square will give you what is this, magnitude of vector a. Then we have null vector. What is a null vector? The vector whose magnitude is 0 is called a null vector. Then you can take a vector, take the magnitude, for example vector a is equal to some 2i cap plus 3j cap plus k, some constant k into k cap. Okay, so if you take the magnitude of this, so magnitude of unit vector, if it is 0, okay, I don't know what the value of k, you can just find out by taking the magnitude here. So if the magnitude of this vector is 0, then that vector is called a 0 vector, and by using this we can calculate the value of k. Let us check. We know that magnitude of a is given by square root of ax square plus ay square plus az square. In place of ax we have 2 square, ay we have 3 square of it, az is k square should be equal to 0. So 2 square is 4, 3 is 9 plus k square is equal to 0. 9 plus 4 is 13, that will come this side. So k square is minus 13. So that you can substitute here. Square if it goes this side, but minus n is there, complex number will come. So that gives you the value of k here. That gives you, I mean, if you substitute this value here, you will get the magnitude 0. Okay, this is called null vector. Then we have negative of a vector. Let's consider there is a vector here which is in this direction. Okay, I need to find out the negative of this vector. Simple, from the same tail, if you extend it backwards of the same magnitude, this will give you negative of a vector, a minus a. Clear? A vector that has the exact same magnitude in length, that represents the magnitude of the vector as the given reference vector, but points in the exact opposite direction, that gives you negative of a vector. Next we have like vectors or parallel vectors. So like vectors or parallel vectors, as the diagram represents, they will be having the same magnitude in length and same direction. Okay, they're called like vectors. Two vectors representing the same physical quantity having the same direction but different magnitude. Different magnitude is not required. Same magnitude also you can consider. Same magnitudes are called parallel vectors or like vectors. Okay, so here we have vector a. This can also be written as ax I cap plus ay j cap plus az k cap. Okay, different magnitudes also. If you consider what happens, ax value, ay value, az value will change. Let it be. Okay, let's consider different magnitude is there. Vector b, which is equal to bx I cap plus by j cap plus bz k cap, like this. Now based on this, we can expect a competitive level question. They will give you a vector like this, two vectors like this, and they will tell that these two are parallel vectors. Now, how to find the value of ax, ay, az and bx, by, bz? They will give 5 values and ask you to find out the 6th value. So just take the ratio ax by ay, ax by bx is equal to ay by by, that is equal to az by bz. That gives you the hint to solve the required data. Okay, this is one thing which is very important for competitive. And here, since they are parallel, the angle between these two vectors will be 0 degree. If we take the cross product, I will teach you what is cross product here. A cross b, in the last page of this session, we will discuss about cross product, is given by the magnitude actually AB sine theta. So since the theta is 0 degree, so sine 0 is 0, so AB into 0 is 0, so A cross B magnitude will be equal to 0. That is one thing to remember. Then we have unlike vectors or antiparallel vectors. Two vectors representing the same physical quantity having the opposite direction and different magnitudes are called antiparallel vectors. So they are having the exactly opposite direction and their magnitudes also might change or different. Okay, that gives you the unlike vectors or antiparallel vectors. Then we have collinear vectors. See, here we have two vectors. Let's consider this is smaller one is vector A and bigger one is vector B. They are along the same line. Two vectors representing the same physical quantity along the same line are called collinear vectors. So if they are in the same plane, they are called coplanar vectors. Look at this, two or more vectors which lie in the same plane are called coplanar vectors. Okay. Then we have co-initial vector. So as the name indicates, initial point or the origin will be same for these vectors. They are starting from the same point and extending to different direction like this. So initial vector. So co-initial vector. Then we have co-terminus vector. That means all the vectors are going to meet at the same point. This is called co-terminus vector. Clear? Then position vector is very, very important. In space, if there is a particle, how do you represent a vector? So that is represented by position vector. It is the vector which represents the position of an object in space from the origin. Here, the position vector is a mathematical vector that specifies the exact location of a point in space relative to the fixed reference point. Usually that is the origin. Okay, that is called position vector. And we have one more important thing, that is displacement vector. Let's consider there are two particles here. Position vector of particle 1 is r1. Position vector of particle p2 is r2, second particle. So what is the displacement vector? The distance between these two, which is taken along this straight line, will give you the displacement. Okay, that is r2 minus r1 will give you actually in this direction we have to take minus r2, right? Okay, let it be. Let me calculate. So according to triangular law of vector addition, if I consider a vector like this is a vector. So I'm reversing r2. This is r1. This will give you yeah, that is correct only. Okay, r2 minus r1 will give you the what is this this vector that is called displacement vector. Okay, these are all the different types. Next we have most important one is mathematical operations on vectors. That is in that the first one is addition of vectors. How do we add vectors? So in that we have three methods. One is triangular law, parallelogram law, and polygon law of vector addition. Triangular law of vector addition, parallelogram law of vector addition, and polygon law of vector addition. So what is triangular law of vector addition? In triangular law of vector addition, it states that, let's consider we have two vectors. So vector B and vector A. You can take vector A, which is having a tail and head, and similar to it, we have vector B, which is having tail and head. What we will do is, I will add or join the tail of one vector to the head of another vector. From that I will get this vector A and vector B. And the resultant of these two, or sum of these two, is represented by R vector. That gives the sum of A and B, that is taken in this direction. Look at this. These three vectors, vector R, A and B, form a triangle. That means A and B are taken in the same order and resultant is taken in opposite order. So according to triangular law of vector addition states that if two vectors, that is A and B, are represented in magnitude and direction, they are having their own magnitude and direction, represented by own magnitude and direction by two sides of a triangle. So look at this is one side, this is one side. Two sides of a triangle taken in the same sequence or taken in the same order also you can write. Okay, then their resultant is represented by, that is A plus B represented by the third side of the triangle. This is the third side of the triangle, taken in opposite order or opposite sequence. So this is called, what is this? Triangular law of vector addition. You can join B with A with B and also do the same thing. So if you consider here, this is vector, this is vector B, then vector A is taken like this, then this is vector A plus B. Again, this is vector A. B plus A is equal to A plus B. You should know that A plus B value is equal to B plus A. This is called, okay, commutative law. That is, triangular law of vector addition or sum of two vectors obeys commutative law. Okay, then we have parallelogram law of vector addition. This is also a method to add vectors. According to this, we take, let's consider we have a vector like this, vector A, and we have a vector like this. This is a vector B. I need to add these two. How do you add? So I will draw a parallel vector here, vector B, and a parallel vector here for the vector A. So this will form what is this? Parallelogram. So if you draw a tangent for this tangent gives you sorry, not tangent, it is the diagonal. Sorry, the diagonal gives you the sum of A and B, right? So here there will be some angle alpha, but angle between A and B is given by theta, which is here. So that is drawn here. Then if you add this, so if you want the derivation, I will do it separately and give that derivation in the description. So that resultant value A plus B is given by A square plus B square plus 2AB cos theta, 2AB cos theta under the root. Okay, under the root. And what about this alpha value? So here alpha value is given by tan theta by sin theta by cos theta, tan theta, that is tan inverse, okay, B sin theta divided by A plus B cos theta. That is the value of alpha here. Clear? Yes. Then we have Polygon law of vector addition. So what if we have more than two vectors? Let's consider here we have one vector like this, one more vector like this, one more vector like this, one more vector like this. How do we find the resultant vector? Just, dear students, draw a vector which joins these two ends, okay, and in opposite direction. So this is the resultant of this vector A. Let's consider this is vector B, this is vector C, this is D, and this is E. The sum of A plus B plus C plus D plus E is equal to vector R here. That is called Polygon law of vector addition. That is, the Polygon law of vector addition states that if any number of vectors are represented in magnitude and direction by the sides of an open polygon taken in the sequential order, the resultant is represented by the magnitude and direction by the closing side of the polygon drawn in the opposite order. Okay, this is called Polygon law of vector addition. Then we have subtraction of a vector. What is subtraction of a vector? It's just the addition of a vector with a negative vector. This is very important. So we can't directly subtract a vector with another vector. We have to add a vector with a negative of another vector. For example, here I have a vector here, that is vector A. I need to subtract with vector B. Let's consider here we have this is the vector B. We can easily find out A plus B by taking the magnitude or resultant for this. That is A plus b. What about a minus b? You just find negative of a vector here. Okay, here that gives you minus b. So this is the resultant of those two. Okay, this is a minus b. A minus b. So this is a plus b, this is a minus b. Clear? Yes. Then rectangular components of vector or resolution of vector. So dear students, here we have one vector in a random space direction. In space it is there. In two-dimensional direction I will take. This is vector A. So how can we write this vector along x-axis and along y-axis? This is x-axis and we have y-axis like this. Clear? I need to write the effect of A on x-axis. So effect of A on x-axis will be coming till here. It's like a shadow. It's called component of vector along x-axis, that is Ax, and component of vector along y-axis is given by this vector. Okay, till here only. This is called vector Ay. Okay, let's consider this is theta. So how do you write theta? I mean A in terms of theta. So that is Ax is equal to A cos theta and Ay is equal to A sin theta. A sin theta. Here if you observe, this perpendicular value is there, whatever it is there, this is called Ax. No, Ay value. Horizontal value, whatever it is there, it is called Ax value, right? So cos theta is equal to opposite by hypotenuse and sin theta is equal to adjacent by hypotenuse. Okay, so sin theta is equal to opposite, sorry, what did I write? Sin theta is opposite by hypotenuse. Okay, let me take it again. Sin theta is equal to opposite by hypotenuse, that is Ay by A. Had I written it properly? No, I had written Ax, right? Okay. Yeah. Sin theta is equal to, in this triangle, opposite by hypotenuse, that is Ay by A. A is a hypotenuse thing. Here vector is there. Just take the magnitude. And cos theta is adjacent by hypotenuse, that is Ax divided by A. So from this we get Ax value and Ay value that I have written here. That is Ax is equal to A cos theta and Ay is equal to A sin theta. A sin theta. Okay, if we divide these two, we will get the value of theta. So Ax by Ay is equal to what? Ax divided by Ay is equal to tan theta. From this we can find out the value of theta, that is tan inverse Ax by Ay. This is one thing. This is very, very important. Okay, this is Ax value. What is this? Tan theta value. Now, how to write A in terms of Ax and Ay? Simple. Vector A can be written as Ax I cap plus Ay j cap. So if you want to find out the magnitude of A, that is nothing but A. It is given by square root of ax square plus ay square. Clear, no? So these are the very, very important results that you must remember. Let us move on to next one. Okay. Next we have three-dimensional one. Okay. What if the particle is present in xyz space, three-dimensional one? Then A is given by vector A. We have to take ax vector, ay vector, and az vector. That is component of A along x-axis, y-axis, and z-axis. So in terms of unit vector, it can be written as ax along I cap, that is x-axis, ay j cap, and az k cap. Clear? Yeah. Now here, if A is making an angle alpha with x-axis, beta with y-axis, and gamma with z-axis, then we can write, what is that? Ax is equal to a cos theta or alpha. That is, here we can write cos alpha is equal to ax by a. A is the magnitude of a vector A, and cos beta is equal to ay divided by a, and cos gamma is equal to az divided by a. Here ax divided by a is the magnitude, that is square root of ax square plus ay square plus az square, and similar here also. So this is called, what is this? This can also be represented by L, M, and N. Okay, so we write these three as direction cosines. Direction cosines. What if we square and add direction cosines? What do we get? So in KCET they will ask you, what is L square plus M square plus N square? So this will be equal to cos square alpha plus cos square beta plus cos square gamma, that is equal to ax by a whole square plus ay by a whole square plus az by a whole square. So if we solve this, we will get ax square plus ay square plus az square divided by a square, that is equal to 1. Okay, that means the square of the sum of direction cosines is 1. Clear? Next we have Lami's theorem. Lami's theorem states that, see here, if you consider a point on that particle or the point, so usually let's consider a particle or an object. So there are three forces acting. One force is acting in this direction, another force is acting in this direction, and one more force is acting in this direction. Okay, so one is F1, another one is F2, and third one is F3. So F1 opposite to it we have an angle alpha, F2 opposite we have an angle beta, and F3 is having an angle gamma. Then according to Lami's theorem, this F1 force is there, right? That is directly proportional to sine of alpha. Then F2 is directly proportional to sine of an angle beta, and F3 is directly proportional to sine of an angle gamma. So we can write F1 by sine alpha, F2 by sine alpha, F3 by F gamma, F1 by F2 by sine beta and F3 by sine gamma are constants, are same. So that is taken as this ratio. Okay, this is called Lami's theorem. So that is given here. Lami's theorem states that if three coplanar concurrent forces act on a body and keep it in equilibrium, it should not be moving, it should be at equilibrium, then the magnitude of each force is directly proportional to sine of the angle between the other two forces. So just look at the diagram and analyze, and remember this formula, which is very very important for competitive exam. Next, we have multiplication of vectors. Dear students, when you multiply a vector with a vector, scalar with a scalar, what do you get? You'll get a scalar again. Let's consider 2 into 2 is equal to 4. Scalar with a scalar, you'll get a scalar again. But when you will multiply a scalar with a vector, 2i cap, what do you get? 4i cap. You'll get a vector again. So, but when you multiply a vector with a vector, you may get scalar or a vector. If you get a scalar, that is called scalar product. Scalar product. And if you get a vector, that is called vector product. Clear? Yes. Then we have dot product or cross product based on this. The scalar product is called also the dot product, and the vector product is called cross product. Clear? So what is scalar product and what is the formula for that, and what is vector product? Let us discuss about it. A scalar product of two vectors is defined as the product of magnitudes of both vectors and cosine of the angle between them. That is, A dot B is given by magnitude of A, magnitude of B, and cos theta. That can also be written as AB cos theta. So for example, vector A and vector B are given. A dot B is found by or calculated by just multiplying the coefficient of I with I, J with J, and K with K. So it is AX BX plus AY BY plus AZ BZ. And how to find magnitude of A and B? Magnitude of A is found by square root of AX square plus BX AY square plus AZ square, and magnitude of B is given by BX square plus BY plus square plus BZ square under the root. You can take any example. Let's consider we have a vector A as 2i cap plus 4j cap plus 3k cap. Just substitute these values here and you will get the answer. And B vector is there. Okay, B vector is given by 3i cap plus 4j cap plus 1k cap. So substitute the values, you will get magnitude of A and B, A dot B and all. So you can also find out the angle between the vectors. So you can just use this formula to find out angle between the vectors. So here it is given here. That is, angle between A and B is given by theta is equal to cos inverse A dot B divided by A magnitude of A into magnitude of B. If in case theta is 90 degree, then A dot B will be 90 degree because A dot B is equal to AB cos theta. Cos 90 is 0. So we'll get A dot B is equal to 0. That means A and B are orthogonal to each other, or perpendicular to each other, normal to each other. This is very very important for competitive exams. And if theta is less than 90 degree, A dot B value will be positive, and if it is more than 90 degree and below 180 degree, that is obtuse angle, theta A dot B will be negative. Next we have few more things about dot product. The scalar product of two vectors obeys commutative law and distributive law. Okay, and the maximum value of A dot B is AB, minimum value of A dot B is minus AB. Then what is I dot I? I dot I, J dot J, K dot K, its value will be 1 because theta will be 0, cos 0 is 1. Then we have cross product. Similarly, A cross B is given by AB sin theta but n cap. A cross B, see, when a vector multiplies the vector, you get a vector again. That's why we have to write unit vector to represent that resultant vector. Okay, but how to take the magnitude? So I will teach that later. So before that, let me find out how to find A cross B. A cross B is calculated by just by taking I cap minus j cap and k cap. So write I cap here. First, when you take I cap, you have to multiply AY BZ minus BY AZ. Then you have to take minus j cap, then take ax bz minus bx az. So when you're taking j cap, you should not consider ay and by. So when you're taking k cap, okay, so take ax by minus bx ay, just solve it, you'll get the answer. Next we have the how to find out the cross product. Look at this. By using right hand screw rule or right hand thumb rule, we find out the direction of that resultant vector. If I consider a cross b, that is c vector, that will be perpendicular to both b and a. So if I find b cross a, it will come downwards. Just hold your fingers towards the vector and curl it towards another vector, that is b cross a. From b to a, that will give downwards, a to b will give upwards. This is how you find out the direction of vectors. Clear? So then we have some things about cross product. If I find a cross b, then a cross b will be always perpendicular to a and b together, and it is not commutative. That is, a cross b is equal to b cross a, not possible. A cross b is equal to minus b cross a, but magnitudes are same. Okay, for highest value of cross product, theta should be 90 degree. For lowest value, theta should be 180 degree. So that is given here. That is about cross product. Okay, then if you find I cross I, j cross j, k cross k, its value will be 0 because theta is equal to 90 degree. AB cos theta, cos 90 degree is 0, you will get 0. But I cross j is k cap, j cross k is I cap, k cross I is j cap, and opposite it will get minus signs. Okay, make a note of all this. Okay, if you want detailed explanation, please text me in the chat box. I'll make one more video for detailed explanation. Bit by bit I will explain, but only on your demand. Okay, so then we have some application based questions. That is, if two vectors representing the two sides of a parallelogram, how will you find out the area? Just find the magnitude of cross product of these two vectors, you will get area of parallelogram. Just take one vector with another vector, cross product, you will get the answer. Let me solve this question in the next session. I'll make separate videos on all this, and with examples you will get an idea about it. Then we have the vectors a and b with diagonals. Then how will you find out the area in terms of diagonals? Just d1 cross d2 divided by 2. Okay, then we have area of the triangle. We have triangle here. How to find out the area of this triangle? See, this triangle is half of the parallelogram, right? So if I consider there is a parallelogram, this side I will draw a line. This forms a parallelogram. Half of this parallelogram will give you this triangle. So we know that area of triangle is parallelogram is a cross b magnitude. Just divide it by 2, we will get the area of this triangle. That's why this is the correct answer. Okay, so this is about this session, dear students. This is just the brief explanation. So if you want detailed explanation, please text me in the comment section. I will try to make a few more videos on this series, and we'll catch up there. Thank you so much.